Hello, everybody. This is Mrs. Wild from Unit 5, Lesson 4. I didn't do a video for the last lesson because I pretty much covered the content of both lessons in my Unit 5, Lesson 2 video. And honestly, there's not a bunch of new stuff from this lesson either. So I'm going to cover one for sure new concept that might be kind of it. So this first section, well, our keywords are frequency, period, wave speed, and wavelength. And we have talked about what frequency and period are already. The one thing we really didn't talk about was the relationship necessarily between frequency and period, and it does show that here. So the frequency is an inverse of the period. Um, the period is 1 over the frequency and vice versa. So if the period is 4 seconds, that's the time it takes for one oscillation, then that means I get one cycle every 4 seconds, which when you divide it is 0.25 cycles per second or 0.25 hertz, right? That's the relationship. Now, when it comes to speed of a wave or velocity of a wave, you just have to realize that these things, they're not brand new concepts. So we've already talked about speed before, way back in first semester, but we've been using it all along, right? Speed, if you think about I'm driving on the freeway or something and I look at my speedometer, it's measured in miles per hour. But in physics, we typically use meters per second. And that's what we're going to be using is meters per second, right? I love how it made my own like a little diamond. We'll keep it. So let's look at it. So meters per second gives us distance, and second is time, right? So how do we measure distance with a wave? We don't really have distance per se, but we do have wavelength. So when I look at the distance from one crest to one crest, that is my wavelength, and that we can measure in meters. If it is a compressional wave, we would use the midpoint of the compression to midpoint of the compression. Okay, and that would be my wavelength. We're going to be measuring primarily transverse waves, though, because they're a bit easier to use. So instead of D for distance, let's plop in wavelength. And time, well, time in this case is the period, the time it takes for one cycle. So wavelength divided by period is equal to velocity. But remember, period is equal to 1 over the frequency. So I can substitute 1 over f for period, and you end up with velocity is equal to frequency times the wavelength. And this is probably the most commonly used formula for the velocity of the wave. And just realize that it is derived directly from your normal speed formula. Distance divided by time is speed, right? Same thing we've been using. Not anything earth-shattering or groundbreaking or anything like that. So you'll be doing some problems with that in this lesson. I'm just seeing if there's anything else that I need to go through. Velocity, frequency times wavelength, da 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 da. I think nothing new there. Okay, it looks like these are just some kind of practice problems to work through. That's pretty much the only new concept in this section. So I'll leave it here and I will see you in the next video.